So the periodic table is organized into groups and periods. Which is which? Which goes up and which goes sideways? Groups go up and down. Very good. And that's by far what we reference the most when we're referring to the periodic table. Is I will say it's in group 6 or group 8. Yeah, sorry. I want to look at our periodic table, but it's covered still. Okay. We will reference our group numbers much more regularly than we will reference the period numbers. So periods go across, okay? Groups are the columns. Sometimes they're referred to as families, right? Sometimes on CK12 or in your book, even they're referenced as families. I will never call them that. That's not how I was taught, and that's just not that's not in my vocabulary to reference them as that. So you'll hear me call them groups more often, okay?
So if you did say group 6, what would that be?
Well, I'll tell you that in just a second. Okay. I would love to answer that question, but I'll answer it with our whole periodic table in just a second. Okay? Within the groups on the periodic table, they have very similar properties. So if an element is in the same group as a different element in the same column, you would expect them to behave similarly. Okay. As you move from left to right on the periodic table, like in a period, we see drastic differences. Like, so for example, if we look at rubidium, strontium, yttrium, zirconium, all the way across down to xenon, those have extremely different characteristics. Rubidium is a group 1 metal. Okay, it's really reactive with water. It's very soft. It has a shiny metallic look. But if you get all the way over to xenon, that's a noble gas, right? It doesn't bond with anything. It's a gas at room temperature. It behaves extremely different. So as you move across, we don't see a lot of similarities. But if you go up and down, like in, for example, group 1, why don't you grab your periodic table? Group 1. Hydrogen sits in group 1 just because of its number of the valence electrons. I'll talk through that later. But the rest of the group 1 metals start at lithium. Lithium, sodium, potassium, rubidium, cesium, francium. Those metals behave very similarly. They look similar. They're soft, kind of almost like butter, but they're metals. You can cut them with like a kind of a butter knife. They have a silvery appearance. They're very soft metals, and they're very reactive. They behave similarly because they're in the same group. Okay, and so that has to do with a lot with the electrons within those elements. And we'll talk about that as we go. Okay, periods go across. Their properties change pretty drastically as we go from left to right. We already gave that example from rubidium to xenon. They are going to have extreme differences. Iodines has pretty extreme differences as well. Antimony is kind of a metalloid, so it acts a little differently. Tin, silver. Those are all examples of really traditional metals, and so everything kind of changes as you move down a period. Although we see changes, it is true that elements that are next to each other do tend to behave alike. So even though like rubidium and strontium are in different groups, they will behave similarly. Not necessarily the same, but the closer elements are together in the periodic table, the more likely that they are to have some similarities. Okay? So let's get into kind of the category of metals. There are 3 main categories of elements on the periodic table. Metals is by far the most abundant. Okay, so I'm going to give you some different properties of metal or metallic characteristics. They're shiny. They're good conductors of electricity and heat. In this instance, what does it mean to be a conductor?
It lets it pass through.
That's good. It travels through it. So heat and electricity travel well through metals. Would give me a metal, an example of a metal that's very true? Iron, copper, the things that we tend to make wires out of, right? That means it's going to travel really well through that. Most of them are solid at room temperature. Do you know the one exception to that? What's a metal that's not solid at room temperature? Mercury. Good. Mercury is really our metal example of being a liquid at room temperature. Most are what's called malleable. Do you know what that word means?
You can bend them.
You can bend it, you can manipulate it, you can pound it into a sheet. That's kind of the definition for malleable. You can pound it into a thin sheet. So what would be examples of metals that are very malleable? Aluminum, good. Iron, tin, right? All of these things that we use to manipulate in really thin ways. Silver, right? All those examples are really malleable. Yep. All right, what about ductile? Do you know what that one is? Ductile means that we can draw it into a really thin wire. We can stretch it into a wire. So what's an example of a good one for that? copper, right? Copper wire is our most common example for a wire, but there's lots of metals that are considered ductile. So those are two kind of buzzwords in terms of metallic properties, right? They're really malleable and they're really ductile. They also have what's called high tensile strength. Do you know what that means?
You can stretch them.
Not necessarily stretch. That's more like ductile, right?
You can like try to like squish it together.
Not really. I want to give the definition almost more as an antonym, right? It's really the opposite of being brittle. Okay, so it's really strong. If I hammer it, it's not going to shatter, right? That's kind of the most basic definition I can give of high tensile strength is that it's not brittle. Okay, because most of our solid non-metals are really brittle, right? They'll break very easily. So high tensile strength means that it's just not brittle, right? So it can also have a variety of different properties. Like we said, mercury is a liquid. Some metals are really soft, like the group 1 metals. You can cut them with a butter knife, right? So they have different properties, but what we consider the true metallic properties tend to be found by the elements right in the middle here. So on our periodic table, the red section of the periodic table is called the transition metals. Those are the ones that have what we consider really traditional metallic properties. So elements like silver, nickel, chromium, gold, those are all metals. Titanium, those are ones that we kind of think of as true metals, right? And they sit in there. Other ones that are on the other side of that, like lead, tin, those are some ones that sit a little bit farther over that still have what we consider true metallic properties. But for the most part, they sit right there in the middle. Okay? So some are soft and some are really, really hard or have really hard tensile strength. All right, so here's some examples. This is an example of a group 1 metal right up here. You can kind of slide it off or almost slice it off like with a scalpel or just something soft like that. It almost has the texture of like butter. Here's a really shiny metal that almost looks fake, right? I feel like the metal almost looks fake, but it's got that really, really shiny property.
It's like crunched up aluminum foil.
Yeah, that's what it kind of looks like, right? This one down here is an example of ductility, right? How thin of a wire we can get it drawn into and it emits that light as electricity runs through it. Here is an example of one that doesn't have high tensile strength. Do you notice how brittle that bottom one kind of looks? So that's a metal that just has a different level of strength or tensile strength, okay?
Do you know what that metal was?
Off the top of my head, no, I can't guess. I can guess. I'm going to think it's somewhere over on the right-hand side. Maybe in the bismuth, germanium type of a metalloid situation, but that would be my guess. I don't know off the top of my head what it particularly was. All right, so the nonmetals. What do you think their characteristics might be?
Not metal.
True, but what in terms of a metal, how would they compare?
Not shiny.
Yes, that's right. They're going to be like the opposite of metals, right? Many of the nonmetals are going to be gases at room temperature. Okay, so they're not going to be solids at room temp. They're going to be gases at room temp. Most of our nonmetals that are solid at room temperature are really brittle. So think of things like carbon, right? That's going to be very brittle until it gets, formed into a diamond. But graphite type carbon is really brittle. They are not good conductors of heat and electricity. Why is that good for us? As humans, why is it good for us that these are bad conductors of heat and electricity?
We cannot
Yeah.
really touch it.
Yeah, because we breathe air.
We breathe air, right? I don't need electricity flowing through my body while I'm breathing, right? That would be a bad thing for me. So we know that it's good for us that they are not good conductors of heat and electricity. I'm going to show you where these are located on the periodic table in just a second. But metalloids, what do you think they kind of are? What do you think?
Between metal and non-metal.
Yeah, like a smush of a metal and a non-metal, right? They have characteristics of both. This is the smallest sector of the periodic table. There's not very many of these, but yeah.
What's an example of a non-metal conducting heat or electricity?
Non-metals that actually conduct heat or electricity, you'd have to get really... So you see this little black solid line? Okay, now I'm coloring over it in green. Do you see this zigzagged line right here? Mm-hmm. Okay, that I call the stair step. Okay, I call it the stair step. And what that does is that gives us kind of a definitive separation between metals and nonmetals. Okay, you've got these metalloids, the yellows, that surround that stair step. But if we have to make a cut and dry decision about where the metals and nonmetals are, it's at that stair step. So metals are to the left of the stair step, nonmetals are to the right. I do want you to draw that stair step on your periodic table. So go ahead and, bring your periodic table out and draw that stair step in there. You don't need to, I don't think, take the time to shade metals, nonmetals, and metalloids. If you'd like to do that, you're welcome to, but you don't have to do that. This stair step is this solid black line. Let me try to think of another color that I could do it that would make it better. But this solid black thick line, I'm drawing it right here. Okay, it just separates it. Kind of give us a clear separation of our metals and our nonmetals. Okay, I would like for you to have that on your periodic table just so we have a better idea. Okay, if you turn over to the back on your periodic table of ions, you kind of see that stair step is drawn in there as well. When you hear me talk about the periodic table in terms of its sections, metals, nonmetals, metalloids, I'll just say the left side of the periodic table. And I don't mean split down the middle, left and right. I mean left of the stair step. So the stair step kind of becomes my reference point. So when I say metals, they are on the left side of the periodic table. That's what I mean, right? They are actually on the left side of the stair step. They make up a majority of our elements. Non-metals are on the right side of the periodic table. They make up a smaller section of our periodic table. And then metalloids is the smallest section. Okay, I'm not going to call it a group because they're not necessarily in a particular group, but they make up the smallest sector of our periodic table. So we need to have that stair step in there. That's going to be helpful for us.